So again, I'm Matt. That's me there, MJ1856. If you're wondering, no, it's not any special year or anything to me. Probably should be. It's just there's 1,000,001 Matt Johnsons in the world, and that's always me. So if you see that on something, that's me. It's just the number I liked. So I want to talk about extending RavenDB, and I'm going to do server side and client side. I'm going to start with the client side. I think much of you are more comfortable writing code for the RavenDB client. It's probably what you spend most of your time in. You might jump into the studio, but on a day-to-day basis, you probably aren't manipulating the backend code. You can, and I'm going to show you how, but first I'm going to show you the client side. Everything I show you client side will work even in hosting solutions like RavenHQ, because you have full control over the code that runs within the RavenDB client. This is stuff that's specific to the .NET client. If you're using the HTTP API, then you would have to do similar things within whatever infrastructure you have available to you. So I want to start with listeners. Listeners are basically hooks in the C# client. We have document store and session, and we do all of our operations on those two objects. So if I open a session and run a query, that's an operation that's telling the session to use the underlying document store object, which is the client, to go talk out to the server. So we want to intercept that query operation and do something, right? So query is one type of listener that we have available to us. We can write a listener, and I'm going to show you how to do one of those. We can register it with the client, and then it will get called with a handler with parameters that are useful to us so that we can do other things that we may or may not want to do. But we can make those decisions within our own code. There's also a type of listener called a document conversion listener. Document conversion listener is basically something that will intercept Raven's process that when you're moving back and forth between your C# classes and the JSON document that's coming over the wire. So if you've got any kind of custom serialization, or maybe you want to pull a field out of metadata and put it into a property, or maybe you want to take a property and store it into a different document or somewhere else in your index, that's something that you can do with document query listener. And I'm going to pause for 1 second because I just realized I'm not recording. If it'll let me. It won't let me. Hold on. Record. OK. Oh, lovely. Full screen. Audio off. Record. OK. OK. So, sorry about the interruption. If it'll come back online here. Yes, yes. OK. So as I was saying, different kinds of listeners available. Document query listener, document conversion listener, I just spoke about both of those. Different things that you can intercept in the process of loading documents or querying documents. We also have traditional things that you might consider like triggers, except these only happen client side. So they're not triggers that are going to run on the server to tell the server to do things. They are pieces of code in your application that you can segregate your normal writes and do additional things. What to do with these is very interesting, and I'm going to get to that later, but I want you to be aware of all the different hooks that are available. Store, obviously for insert or update, we have a delete listener. We also have a document conflict listener. So if you are doing some of the advanced replication scenarios we talked about, this is your opportunity to deal with documents that have been written as conflicts and decide on some custom behavior. So I want to show you a couple of these in code. I'm not going to go through them all, and I'm trying to be cognizant of the time. But let's look at a typical listener. So I've got a very simple sample here, and let me just kind of show you from the top. So I've got a customer object that just has a name, an ID and a name. And I'm going to do a simple map reduce query here. So I've got the result. I'm going to come back. I want to know how many customers are named Bob, or all customers count by name. And there's my map reduce query. None of this should look foreign unless you never use RavenDB. Let me just zoom in and see that's kind of small. So I'm counting one customer per name, and I'm summing these up. This is a traditional aggregate sum. And that's all I'm going to do. But when I run this, what would I expect? So I'm going to add some documents, register the index. I'm going to add some documents, and then I'm going to query for those documents. And we'll see what happens here. I should get back the results that I'm thinking of, right? So should I left that open? You can see that, yes, we are going to fail. So why did I not get back any results? Somebody should know. I added a whole bunch of documents, and I queried back for a page of documents, and I got nothing. Exactly. No, the index deployed. Close. Eventually consistent. That's right. This is a unit test. I just read the documents, and I'm querying it right away. In real life, you want to leave time, and your users should expect time, and that time can be very small, but it normally happens. But in a unit test, you have to introduce that artificially. So what do? We normally would go to our query and say dot customize, and I'm not going to use the test helper part for this, just so I can kind of show you how you would do it without it. What's going on here? Customize x equals x dot wait for non-stale results. But say I got like a whole bunch of queries going on, or maybe my queries aren't in the unit tests. My queries are actually in the logic that I'm deploying elsewhere in my application. The last thing I want to do is have branching in my code that says, if I'm running and testing, run the query with waiting, and when I'm not running and testing, then take the waiting away, right? So you really don't want those wait for non-stale results to be anywhere in your code where the queries were really residing in your normal application. We saw the query object pattern earlier. Was that in Kijana's? Was that in your module? And if you are using a query object, the last thing you want in a query object is a wait. But I still need wait behavior for my unit tests. So one thing I can do is in my unit test, I can wire up a query listener that performs the wait. So right shortly after I create my unit test, I'm going to say document store register listener. And I've already created this listener called a non-stale query listener. This particular one is straight from the RavenDB sample. If you go to the RavenDB documentation and look up listeners, you'll find this one. But let's pull it open so you can see it. That's it. It's very, very small. We implement iDocument query listener. That's the interface coming from the RavenDB client. And it gives us a method to implement for our interface that takes in the iDocument query customization. That is the exact same thing that I got when I said customize X. And in that X, that's the Lambda that's here. So I'm doing anything that I could do in there, I can do right here. Once this is registered, every query that runs through that particular document store is going to run through this query behavior. So when I run this again, now that it's wired up, it should pass. Very straightforward. And we'll see here success. So there's my MapReduce index with its counts, and it waited for those results, waited for the index to build. And I didn't have to wire the wait for non-stale results to the specific query. I just wired it up as a document query listener to the client. So that's a very easy way the client can be extended. Let's look at one other type of client-side listener. And again, I'm not going to demo them all. I encourage you, if you're interested, to try to play some of the samples, try to come up with some of your own use cases. There are plenty of ways that this can be infrastructural as well as it can be domain specific. So think through why you would want this kind of thing before you just jump into it. Here's an interesting example. I'm going to use a document conversion listener, and I'm basically going to use it to take Raven's last modified metadata that it's creating, and I want to move it to an actual property in my entity so that it's more readily available. Maybe I actually want to pass that down all the way through to my API and have it deserialized out. Well, if it's left in metadata, I could use on the client session advanced get metadata for entity and then pull the metadata field out. But really, I just want this converter to do it for me. Now, I've done one little thing that the sample on the website didn't do, and this just kind of makes it simpler to apply. So I don't necessarily want to put this on everything. So I created an interface called I have last modified property, and this is it. It's just, that's the property. And if I go to the class where I'm using it, I just decorate it with that property. This is one way you can help control your listeners so that they can act generically instead of specific. What I wouldn't want to do is tell my listener to watch for a customer object. It's more appropriate that since it's a last modified updater listener, that it's looking for a last modified date. Now, I could also use reflection, or there's a number of other ways that you could go about finding that if you don't want to mess with the original properties, but this is the simple way. So now when I save this document, I'm not going to write the last modified date. Raven's writing that for me in its own metadata. So when I store it, I don't pass it in, but when I get it back out, it's going to have it because I've registered that conversion listener with it. So we'll just run that. And you should see here that I store the object, and then when I retrieve it, there it is. The last modified date was populated. And that came from Raven's last modified metadata that it added and sent back to the client, and then the client listener specifically took that off the metadata and put it down to a property. Any questions on that? It's a lot of like misdirection, right? I feel like a magician when I do some of this stuff. You can make the client behave in different ways than it normally would just by teaching it a few things. And if you teach it things that are useful to you, you can do all kinds of powerful things. And I'm going to show you some examples of some things you can do with it that are above and beyond. Before I do that, so those are the kinds of listeners. Let's talk about serialization. This is another thing you can do client side. So JSON converters. So anybody use JSON.NET outside of RavenDB? Lots, yes. JSON is probably one of the best serialization libraries I've ever seen. Lots of kudos. But one of the things that becomes challenging with any kind of serialization is controlling that serialization. If you've got objects that you've created in your domain because you've been following domain-driven design, which is a very good thing, and you've gone to the effort of creating custom value objects, which is a domain-driven design concept, you might find that when you go to deserialize them by default, you get weird behavior. Maybe you've got properties on those objects that really shouldn't end up in the JSON form. Maybe you've got tree structures that end up getting recursed on and causing lots of loops. Maybe it won't serialize at all and it'll throw an exception because you get a Stack Overflow in trying to serialize it. There's lots of little things like that that can come up along the way. And rather than saying, well, gee, I can't write my class the way I would like to write it, the way that makes most sense for my domain, because the infrastructure doesn't handle it, it's a lot easier to say, you know what, the problem is with the serializer, and it's not that the serializer is bad, it's just that it hasn't been trained for my objects. So JSON.NET has this idea of JSON converters. A converter is a class that has a read method and a write method, and you can override them and input your own implementation and to go back and forth between a .NET object, a class, or a struct, and a JSON document, a JA object. Since Raven implements JSON.NET, it's got full support for JSON converters. So you can very easily go to the client and say, register custom serialization and append your own converters in there. I'm not going to do a demo of that just yet, but I'm going to show you where I did that in the Node-a-Time project I showed you earlier. Another thing that I use in that Node-a-Time library is something called query value converters. This is a similar concept in that I have some value object that I'm passing into a query, but this time it's not JSON.NET that's doing that serialization. It's RavenDB's client that needs to understand my object to know how to write it back out to the actual Lucene that goes into the query. When you saw earlier, I was querying by an instant. Well, Raven, JSON, they don't know anything about instants, so I have to teach it first how to serialize an instant, then I have to teach it how to wire up that instant to the converter. We also have this idea of query translators. This is a slightly more advanced concept, but it's related to that query value converter. I don't have an easy way to explain it, but I'm going to show you. And I'm going to do that real quick, and then we will look at server side. So what I want to do here, sorry, I should have this one wired up. I'm going to pull open the actual internal guts of the RavenDB Node-a-Time extensions that I showed you earlier. And we're not going to focus on the time bits of it, but we want to focus on how it interacts with the Raven client so you can get a better understanding. And this is all out on GitHub right now if you want to take a look deeper. So let's just look at the client side. If you saw earlier, I had an extension method that said configure for Node-a-Time that I wired up to the client to tell it how to do it.
these are all the things it's doing. First, it's adding a bunch of custom serializers that I've created for Node-A-Time. Some of them were written for Node-A-Time, but then ported to Raven because Raven has its own copy of JSONnet sitting in raven.imports.jsonnet. So if you've written a JSON converter and you're using it like in your web API project, unfortunately, you do have to re-implement it again in Raven so that it can be wired to the Raven client. Usually, that's a matter of cut and paste. You can do some interesting techniques like file linking in order to share those if you can control the namespacing. Sometimes you have to write it twice, and unfortunately, that's just a side effect of this. It's worth the pain, though. The particular converters that I've added, I'll just show you one. I'm not going to really dive in too much, but here's the general idea. I have, actually, that's a bad example. I'm sorry. Let's look at. OK, well, don't worry about what it does, but notice there's a read JSON implementation, and there's a write JSON implementation. So within the body of that, you get a lot of control. The net effect is that I'm taking that custom object that I have, and I'm putting it into a JSON structure that I'm controlling. I'm basically training JSONnet on how to work with that. So that's as simple it is. And we do serializer converters add. And the serializer itself came from the Raven document store. In the conventions, you have customized JSON serializer. This is a delegate that gets called when Raven wires up the initial JSON serializer. So it's a delegate body, and everything I'm doing is inside that body, inside this Lambda. We've got a lot of little things in here. Some of it's just from using it over time, so this isn't the best demo code, but this is more production quality code. So I registered the JSON stuff, and then I have to register this particular library needs both query value converters and some custom query translators. So I'm just going to kind of show you an example of one of each. So here's a query value converter. Basically, I get some methods for, there's my constructor. I've got some static methods that I set up here. And then, actually, I've got quite a lot of them in here. I'm sorry. Each one of these is a separate converter. So it's the function signature that, and I take in the name and the object of the type that I want. So this is of t, and a query value converter type, and I output a string. I also need to return true or false because maybe I've got something that can't be parsed, so it's a lot like try parse on any of the built-in .NET objects. Again, I don't want to go too deep on any one of them. The query translators are a little more complicated, but they're similar results. This is basically how do I participate in the link abstract syntax tree. So I'm writing a link query, and I'm providing a method that is unknown to Raven and unknown to .NET. How is it going to behave in that link query? So by having these query translators, you can participate in that process. Again, getting into like dissecting the abstract syntax tree and why I'm calling which expressions and why here is more time than we have. But needless to say, it's augmenting Raven's approach to analyzing the link query that you're giving it so it knows how to build the call going out to Lucene. So those are pretty much how I wire in to the client. And you can do the same with your own. So like I said earlier, like date and time is a very small domain, right? And Node-A-Time is a very specific implementation of that small domain. But maybe you've already, through your own analysis, identified certain value objects and operations that don't need to happen on the server. They happen in your own code, but maybe they're part of something that's more complicated, and you need to be able to express it in the query. That's what something like query value translator could do, as well as some of these other things. So the facilities that Raven gives you are both listeners, serializers, converters, those kinds of things. Yes?
Can you talk about, are there any performance implications of having a whole ton of...
Not much. Be careful what you do. You could very easily create endless loops, just like you could do infinite recursion on trees or things like that. But none of these things happen on the server, and they don't slow the client down by too much. It's especially here, what you're building is training an abstract syntax tree. JSONnet itself is optimized for running through converters, so it's already got that process set up for it. I would assume there's not much overhead in wiring up the translators into the Raven client. It's just jumping through a few hoops so that you get a little bit of extra value.
The way it actually works, you only get called for translator or converters if we don't know how to deal with them already. So for all of the standard operations, you don't care. You don't even see that.
Okay, so keeping an eye on the time, I want to jump right into server-side stuff. So lots you can do on the client. If you have full control over your Raven server and you're very careful to what you do, you can customize some of the behavior on the server. This is done primarily through bundles or through plugins, which are related to bundles. The best way to think about it here is that a bundle has one or more plugins. So I may have a single plugin all by itself. If I want to be able to push that to a Raven server instance, it's got to go into an assembly that's going to sit in the plugins folder. That assembly is called a bundle, and we give it a name so that it can be loaded dynamically. The name is actually optional. I don't know if that's by design, but it actually comes in handy. You do have to be very careful with it, though. If you don't specifically export a name on your bundle, it will be loaded by every one of your databases. So I use nameless bundles only if there's no triggers in the bundle. So like when I'm wiring up notatime stuff, it's all just about making sure something's available if the Raven processes already do that, or if they need it, right? So if you don't go out of your way to use a notatime type, the fact that it's registered through a plugin that happens to be out there and loaded isn't going to hurt anything. However, if I'm intercepting something on a trigger, or I'm doing some kind of startup action, or any of these other types of plugins I'm going to show you here in a minute, it's really important that you name it so that individual databases can choose whether to subscribe to that plugin or not. The last thing you'd want to do is deploy a trigger on a specific database and find out that every database on your system, including the Raven system database, is affected. And this is an area where you can get performance implications, so you really have to watch out for what you're doing. We tie in bundles using the active bundles setting. This is found for the system database in the Raven config file, along with all the other config options. For individual databases, active bundles is in the document that is established for each database in the system database. So it's very easy, like when you go turn on and off a bundle using the UI, you'll see that there's a single string called active bundles that's semicolon delimited, and you simply just append the name of the bundle on, and as long as that name's in there, then the bundle gets loaded. By the way, I called out here, everything is using MEF, which is the .NET Managed Extensibility Framework. It's built into .NET 4.0. Yeah, that's a 4.0 thing. MEF is a really, really good way to write plugins. I'm really happy that Raven uses MEF for plugins. It's not doing a whole lot of custom stuff. It's a very simple way to either just wire something up directly or scan a directory to wire things up, and interfaces exchange with each other very, very well. So if you're getting confused at all with terminology, just think that plugins provide behavior and bundles help provide the plugins to Raven. Bundles wrap that behavior, and it could be one or more plugins working in concert with each other. I'm going to show you some examples of that later. Yes, they are loaded separately for each database based on that active bundle setting. So these are the kinds of plugins that we have. We have triggers, which are just like they are in SQL databases for the most part. A little bit of variations, like we don't really have the concept of instead of triggers, so there's some behaviors you can do in order to work with that. It gets a little complicated. Most of them are things you would want to do in addition to the default behavior. So you can intercept puts, deletes, reads, updating an index when the index is actually pulling out documents to do its work against the index, as well as clients coming in to query the index. So this is like your get, and this is query. All this is from the server side. So you're sitting inside an assembly that has access to the internal workings of Raven. The other thing you can do is codecs. So these are used primarily for things like encryption and compression. In fact, the built-in compression, basically all the built-in bundles use all of these types of plugins. So if you're wondering how any of the existing features are implemented, or you're trying to do something similar but slightly different, you can look at the current implementation and start with that. I just urge you to test over and over again. You need lots and lots of unit tests when you're writing
plugins. The last thing you want to do is throw something out into a production environment and be on the phone with hibernating rhinos because your production environment is failing and it turns out that it's a plugin that you either wrote yourself or maybe you took one of mine. You always still want to test. Plugins change the behavior of the database, for better or for worse. Startup tasks. So things like the document expiration bundle use startup tasks. It's basically saying I need a process that can fire periodically, wake up and do something. You register that in your bundle, and then it doesn't matter what's happening on your server. If the time has elapsed, then it kicks in and does whatever you ask it to do. There's lots of good uses for that. Compilation extensions. This is how I showed earlier how no-to-time types could work inside a static index definition. It allows you to export one or more assemblies and make them available to the query engine that's interpreting the actual index. Not the query engine, but the actual index runtime. So if you've got some custom business object, really they should be in your client side, in your domain, and you should try to keep them off the server as much as possible. But you may find value in some cases of making them available to your index. What you really want to be careful here is that they don't have side effects. The last thing you want to do with indexing is reach out to something that's expensive. If you see like you want to say something on that. Sure.
There are actually two things that you have to be careful about when you're doing indexing. When you're doing compilation extension for indexing, one of them is that, as Matt said, no side effect. You talked about the side effect of slowing the system down. That's not that much of a worry. RavenDB assumed that indexes are pure functions. And by pure functions, I mean that they are given a certain input, they're always going to be the same output. Yes. And if you go and the trivial example is you want to do datetime now in the index. And we actually throw an exception if you try to do that. We won't allow that index to compile because that's now no longer deterministic, that now every time that you run the index, you're going to get a different result, and that breaks a lot of environment inside RavenDB. So I've seen people who, during indexing, made a web service call per index, and that went to a remote database, to a SQL Server somewhere, pull a big XML and did stuff. And leave aside the fact that it generated very, very, very slow indexing. It also made it so you run the indexing one time, and based on the data on a completely other database, you get very, very different results. And that was horrendous to debug.
Well said. There are a lot of really great uses for plugins. It's one of the more powerful features of Raven. But what's popping into my head is, the phrase, "It's your foot." I'll give you the gun. You decide whether you want to shoot it or not, right? So if you're careful what you're doing and you understand the architecture and you take your time with it, you might find something that's useful to you. I would urge you to consider, from a plugin perspective, think of things that are infrastructural that don't belong in Raven core, things that wouldn't make sense for hibernating rhinos to develop and put out as an offering, but might make sense for you. That doesn't mean they're tied to your business logic. They should be more infrastructural things. Not to say that they couldn't be, but that's the kind of mindset you want to have when you're writing plugins.
Just one point, not necessarily stuff that we wouldn't do. A lot of the actual behavior in RavenDB are stuff that is implemented as bundles. Replication, SQL replication, expiration, versioning, those are things that you want to be able to turn on and off. And it's also very helpful to be able to think about them separately. There's a lot of stuff that people have been doing, being able to, whenever a message comes, so the changes API, for example, we have people that want that to go over they wanted to go over 0MQ channel to remote machines, or they want to do transformation or over additional channels or all sort of crazy stuff like that. And those are good places to actually extend RavenDB. And because we're using the bundle architecture for everything, there's a lot of things that you can do without ever touching the RavenDB codebase directly.
Exactly. So there's a couple more just to mention. Analyzer generators are an interesting one that I haven't spent a whole lot of time with, but this, I believe the general idea is that if you're writing your own Lucene analyzers, this is an easy way to get them into Raven. And then database configuration, you may find it easier to deploy an assembly that modifies the Raven configuration settings so that you're not relying on config files or some other process. It could also be that you're writing as a bundle, putting several of these things together for a specific purpose. And perhaps in order for a specific delete trigger to work, you have to set a specific database configuration setting. So you would put those things together so that you've got the opportunity to do both as one bundle. I'm going to talk about those in a minute. Let's just give you an example. So I'm going to do some really stupid things just to show you kind of like how it works and what not to do. But let's talk about, not node to time. Let's go back to here. Plugin demo. So I've got, again, I'm just going to write a document. This time, I don't want to even involve query for this test. I'm just going to kind of show you that, hey, I can control something that happened on the server. So all I'm going to really do is just write one document. Okay, very, very straightforward. But I'm going to add a put trigger. Okay, this is a very stupid put trigger. I just call it stupid put trigger. Notice how I add it. I'm not scanning for anything. I just want to test this one plugin. So this is all meth. Like Raven just exposes its catalog. So if you're not familiar with this syntax, you don't have to bug us with it. You can very easily just Google it, and there's plenty of stuff out there on how meth works. But I could just as easily put this in its own assembly and drop it into a folder and scan for that assembly. There's lots of ways to build meth catalogs. All I'm really interested at this point is I've got one class as one plugin. I don't want the bundle wrapper. I just want to load it, right? I'm going to do exactly what I said not to do here and put a put trigger without a bundle name. So because this is not named and I loaded it, any instance of this server, which is an embedded server, is going to run through this put trigger. And this is a stupid put trigger. It just says, no, you're not allowed to put. So that would be very, very useless. But it gives you the opportunity, as you can see. I'm overriding the allow put method. And I've got lots of other objects that I can do. I could make a different decision on whether you're allowed to put. I've got on put, so actually when it happens. I've got after put, so I'm done putting it, but I haven't yet committed the transaction. And then I've got after commit. So you can involve your own logic at various stages in the process. After commit is really interesting because in theory, you could do things that were expensive as long as you spun up another task, so your client's not going to hold on. Your client can be returned, and your server's off doing whatever you told it to do in an asynchronous manner. All those things are possible. Just to show you that this does work, I wired it up, and in not so much code here, it should fail saying, no, you can't put, where is it at? That's the wrong one. Yeah, there we go. So I get an exception. I return a message, and yeah, because you're not allowed, ha ha ha. I encourage you to use that message to your users. Oops, sorry, didn't mean to click that. No, back out. Back out, I did not want to debug. Okay. So let's look at something slightly more useful. But again, I'm not gonna give you like, here's a really great plugin that you should go put into your own code. I want you to spend time thinking about it. So here's a different thing I could do during put. I'm not going to bother with am I allowed or not. I'm just going to say I'm going to do it. Anytime I get in one of these customer objects, I'm going to duplicate it, and I'm going to increment the key. So you're going to end up lots of duplicates in your database. So again, this is something crazy that you wouldn't really do in production. But I wanted to demo to you how you can do this. All we're going to do is go back to this, and instead of wiring up the stupid put trigger, we're going to wire up the crazy put trigger. Well, let's see. So I'm going to run this, and I did wire up the
the test helper, so it should launch the studio since I'm going in debug mode. What I should see here is the document I put and one more document. Sure enough, there they are. So I put customer name Walter, and the plugin took the put operation and cloned it. Let's look closely inside of that. And like we were saying, or he was saying, what happens if the put operation causes the put trigger to kick in again, which causes the put trigger to kick in again, and you get an endless loop, right? So where'd it go? Crazy put trigger. So in order to prevent that from happening, this is very important incantation. Database.disable all triggers for current thread. Anything that your trigger is going to do to modify the database, it's really important that you do it in the body of one of these statements. Unless you're intentionally depending on that side effect. The thing is you won't know at runtime what other plugins are loaded. You'll have absolutely no idea. Your plugin, sure, it could go out and say, if the versioning bundle is loaded, then do this. But really, it shouldn't be doing things like that. It should only have awareness of itself, right? So to prevent that kind of cascading behavior that can lead to server crashes, that goes in there. I'm just going to kind of show you what would happen if we turn that on. And again, I'm going to go into debug mode. Plugin demo, run, please. And what you're going to see here in a minute is, well, we'll see how far it'll get. So I'm doing the thing you definitely don't want to do, which is to not be using that disable trigger for all threads. Oh, there we go, Stack Overflow exception. So I couldn't even get the studio launched. Before I even got to that spot that it said allow the user to launch the studio and wait for debugging, before I could even get there, the server got caught in this life cycle of put, and it overflowed the stack. And I'm just doing this in memory, so eventually I ran out of stack space. If I was doing on disk, I might just be sitting there overflowing my disk. So this is where I was saying you have to be very careful about what you're doing. The syntax for some of these methods may look a little bit foreign. The few that are very helpful are obviously anything that comes in on one of the input parameters. You're going to see the documents and the metadata split out as Raven JObjects, which is basically Raven's implementation of the JSON.NET JObject class. And you're going to have the document key, so you can make decisions based on that. You can also go through the metadata, and I strongly recommend this syntax. This is an interesting kind of collection that JObject has. But using that form, value, and then type, if that object that I'm looking for isn't there, I will get back a null. If you use the other syntax, so let me comment this out, and say, Raven entity name, which is what's in that constant that I'm using. If that key doesn't exist, you will get an exception thrown. And if exception throws in your bundle, then you're going to get an error somewhere in your application, or it could end up crashing the server in various ways. So I recommend this particular syntax. Of course, it really depends on what you're doing. I like using the constants. Most of the constants are defined here as properties that you can very easily get at. Helps prevent typos and stuff from well-known types. So like there's all the different constants that Raven's got internally. And those are all found in the Raven database assembly, which has to be referenced from your bundle class anyway. So if you're going to use or I was using last modified, well, there's Raven last modified right there. So it'd be better to say constants.Raven last modified. Actually, these are in Raven abstraction, sorry, not in Raven database. So I mean, that's pretty much it that I'm going to demo as far as like what you can do with server-side triggers or plugins. Does anybody have any questions specifically on server-side plugins?
Bundle search pattern, how is that interact with the active bundles?
I'm not sure exactly.
I'll ask you offline.
Yeah, I'm not sure exactly. I'd have to dig into the specifics on that one. Okay, so yeah, we're going to wrap it up because we're getting close to the end of the day and we're over time. I just want to point out that there are quite a few things that are already available as open source projects, several which are mine. We started a Raven Contrib project to try to get more community development into the project, and there were quite a bit of things published there, both by myself and others. It became apparent over time that some of the things that were in there were too niche to be lumped into a single project. So some of the things I had, like the index attachments, was originally in the Raven Contrib project, and we moved those things out. You will find that I'm not the only one writing stuff for RavenDB. There are plenty of other GitHub things. We saw earlier an MVC membership provider for RavenDB, although it's not really extending Raven, that's just providing additional features on top of it using Raven. But these are things available now. The three at the bottom are things that I'm continuing to support personally, although the index attachment things I'm going to probably revisit after I see how indexing attachments works in Raven 3.0. But the general idea with that one, I don't have time to demo it, but the general idea with index attachments is that you can paste an attachment, and during the process of putting that attachment, an attachment put trigger kicks in, and it invokes something built into Windows, which is called an iFilter. And if you have an iFilter registered for the document type you're posting, such as I'm posting a Word document or a PDF document, it will extract all the text from that, and it'll dump it into a Raven document where it can actually be indexed using Raven's normal processes. Works really great for trying to do hit highlighting and stuff. If you want to use Raven as your primary CMS, you can do that with Index Attachments Bundle. There's a lot of advanced things that come out of that. But as we know, attachments are not as good as they should be in 2.5, and they're going to get better in 3.0. So we'll probably lean towards that.
No, they are not.
Yeah.
They're moving to RavenFS.
Good. So I'll probably be looking to either contribute bits to that or to modify this to work with that. So we'll see how that goes. Note of time we saw earlier. I want to talk just briefly about temporal versioning. I don't have time to show it, unfortunately. This is a really interesting bundle that I spent a lot of time on. Actually, my former employer spent a lot of time developing this and contributing it back to the community. The idea with temporal versioning, it's a very complicated subject, but the general idea is if you've got something in your business domain that requires an effective date. So our particular use case was a manager is giving an employee a raise as of next week. I don't want to just go into the employee's object and change their pay rate. I want to specifically say, as of next week, their pay rate is, and change it that way. And one route to handle that from a domain modeling perspective is to build out what's called temporal property, where you have a list of items and says, from this state to this state, the value is this. From this state to this state, the value is that. Because you don't want to just overwrite the old value, or you'll be giving him his raise right away, or you'll be overpaying him or running your reports wrong. There's a lot of things that can go into that. Doing that repeatedly over and over again becomes a burden. If you have one thing that needs to be done on that, go ahead and do it that way. It's like your history tables in a traditional relational database. But if you've got significant temporal concerns where you're saying, you know what, anything that changes to this thing, I need to keep an effective date on, and I've got lots of those things scattered throughout, it's a lot easier to make that an infrastructure concern. So this versioning bundle has many plugins and a client that work in concert, and basically allows you to say, when I store something, it's either effective right now if I don't tell it anything else, it's just effective now, and it behaves like it would if I didn't have this installed. But I can also say, this thing that I'm saving is effective next week, effective next month, whatever the date is, you can pass that in as a parameter. And then when I query back out, or I'm loading that document through load document on indexing, or many other different places, you can provide optionally a date. So you can say, I don't just want it as of the value now. I'm running a report effective last week, so I want the value as of last week. And you can do joins across that data as well. Not really like relational joins, but the same kind of load document style joins that Raven normally offers. Basically helps you align your references to other things. The main difference between temporal versioning and Raven's default versioning bundle is temporal versions are indexed. So if you're using Raven's versioning bundle, that's great. It keeps a really good audit trail of all your changes, but they're not indexed. You can't query against them, and that's intentional. Temporal versioning, you can query against them, but you have to provide that effective date in order to get back at old versions. You can also replay an audit trail the same as you can with the Raven versioning bundle. The one area that this has not been fully fleshed out, if you're going to play with it, be very careful about replication. That's something that I'm working on still. So if you're putting it into a production environment where you're going to have replication, you're probably going to have a lot of conflicts. It needs document conflict listeners and plugins added to it in order to resolve those things. So just be aware of that. Anyway, all this is in the open source, and I encourage all of you that if you're doing stuff with Raven, please look at the Google group, look at Stack Overflow, look on GitHub. There's a lot of interesting things out there for all kinds of databases, and Raven is one of them. So don't think that the only thing you can get from Raven is what's coming out of hibernating rhinos. We have a really good community, and it's getting richer and richer, and I encourage you to participate in it.
So that's all I have to say. Thanks for staying a little bit late. Questions? Okay. Thank you all.